Hi everyone. So we'll continue the discussion on EM waves. So next one, protection of EM waves. Protection of EM waves. First we'll discuss. Listen, like this is what is Hertz experiment. Hertz experiment to produce EM waves. Okay. So this is the setup is like it is given in the textbook. You can check it. And I need to focus on 2 points. So that is why I have given this diagram. Okay, usually the experiments and all I tell you to refer, right? So here I need you to focus on 2 points that I will tell you. Listen. So first of all, here 2 plates are there, 2 capacitor plates are there, and in 2 capacitor plates, if what Hertz has done is like he had given a high voltage to this, then what happens? It will get charged. This capacitor plate will get charged. Then here 2 things are there, or 2 like what knobs are there, and these are like I'll draw it here. Okay, this is a plate. This is a capacitor plate, and there is a knob like this. Okay, so what will happen is when it gets charged, this knob will get more charged because principle of action of points. Principle of action of points. We have learned this in electrostatics. If you have doubt, you can check it. Okay. So principle of action of points. This is a uniform surface. So something is projected outwards. If some portion is projected outward, then what will happen? Here the charge density will be maximum here. Charge density will be maximum here. Then what will happen? Corona discharge will happen. Alright, so corona discharge will happen. So there will be a discharge over here. So there will be sparks over there. So what will happen? The electromagnetic wave will produce. This electromagnetic wave, what is this? This receiver, or it's a ring kind of setup. So this will detect, this small gap will detect the electromagnetic wave. Okay, this is the experimental setup of Hertz experimental setup of production of electromagnetic wave. So why I am emphasizing this thing, because like there is something called which is this principle of action of points. You can expect a particular question that is connected with both electrostatics and EM waves. Alright, so we have learned it in electrostatics, and the application of that we have learned it here. Alright, so there is a question that like it's not a very important topic, but even though if there is a chance, we shouldn't miss that chance, right? Oh yeah. Alright, so again, sources. Next, what are the sources of electromagnetic waves? So there are 2 sources. First one, a charge which is oscillating harmonically. Like listen, if a charge is oscillating, then there will be an electromagnetic wave production. Why? Because if a charge is oscillating, apparently there will be there is a changing electric field. The changing electric field can produce a change in magnetic field. So that may cause the production of electromagnetic waves. Alright, the second one, LC oscillator. Okay, LC oscillator, this we will study in the EM1. Okay, in AC alternating current. So it's an LC oscillator. Alright, so these are the things about the production of electromagnetic waves, and just read about the experimental setup of electromagnetic waves and the other things as well. Okay, alright. So let's come back to the properties of EM waves. This is one of the important topics of EM waves, and there are like a couple of topics only. But one of the important topics is this one, properties of EM waves. So there will be some questions from this topic. Alright, so first one, speed of EM waves. So one by one we will discuss. Alright, so first one, speed of EM waves. What is the speed of EM waves? In free space, we know that all the electromagnetic waves have the speed which is c. What is c? Velocity of light, 3 into 10 to the power 8 meter per second. Alright, so what is this? This is nothing but 1 by root of mu 0 epsilon 0. 1 by root of mu 0 epsilon 0. Or also we say that c is equal to E0 by B0. E0 by B0. Okay, and again, this is for free space. This is for vacuum. You know that if medium changes, in optics we have seen that if medium changes, the velocity changes. So then, what will happen? V is equal to, at medium, and in any medium, V will be equal to 1 by mu epsilon, 1 by root of mu epsilon, 1 by root of mu epsilon. So what is mu epsilon? This is permittivity in medium, and impermeability in medium. This is permittivity in medium. Or I can say that mu, it will be V also equal to 1 by root of, this is just a recall. What is mu? Mu 0. I mean, what is mu? Mu 0, mu r. What is epsilon? Epsilon 0, epsilon r. Alright. Okay. So again, next is energy of EM waves. What is the energy of EM wave? So UE, energy of, we know that there are two components, right? There are two components, electric field component and magnetic field component. The electric field component energy will be equal to half epsilon 0 E square, and the magnetic field component will be equal to like half B0 square by U0. Alright, so this, please look at this. We have to use it many places. In many places we have to use the same thing. Alright, so again, what will be the total energy? Total energy will be equal to UE plus UB. Okay, UE plus UB. So you just add them, then you will get the total energy. Alright, so next one, intensity. What is intensity actually? Intensity is nothing but the total energy is propagating, or total energy is propagating through a particular area in a particular time. That is what is intensity. What is intensity? Total energy per unit area, I mean total surface area per unit time. That is what is total intensity. So the intensity is nothing but, or you can say the total energy density into volume divided by surface area into time. Why? Because total energy is nothing but, energy is equal to energy density into volume. Or what is energy density? Energy per volume. So this will be replaced by this one. Okay. Again, what is the value? Value will be half epsilon 0 is E0 square into C. That is the intensity equation. Please keep in your mind. That is the intensity equation. And half B0 square divided by mu0 into C. That is what is another equation of intensity. Alright. Again, next is very important thing, Poynting vector. Okay, all of you take that Poynting vector. Okay. So this is nothing but Poynting vector is a special quantity which is defined for, or special parameter which is defined for EM waves, which is nothing but like the total energy flow per unit area. That quantity we represent it as Poynting vector. Okay, Poynting is a scientist. Okay, so Poynting vector is nothing but it is a total. In some other place also we will discuss about Poynting vector. So anyways, Poynting vector is nothing but it is a total energy flow per unit area. That is known as Poynting vector. We represent by the letter S. Okay, yes. So which is equal to, S is equal to 1 by mu0 into E cross B. It's a vector, so E cross B. So or C square into epsilon 0 into E cross B. Why? Because mu0 epsilon 0. From this is very important relation. Look at this. C square is equal to 1 by mu0 epsilon 0. Like you can just take the square. Then what is epsilon 0? Epsilon 0 is nothing but C0 square into mu0. You got me? Okay, you can just interchange them. That is what we have done here. Okay, 1 by mu0 E cross B, or C square epsilon 0 E cross B. Alright. Again, next is radiation pressure. Alright. So what is radiation pressure? And before going to discuss about radiation pressure, I would like to discuss momentum first. Momentum is nothing but momentum is a linear momentum, energy per speed. So in a reflecting surface, so that I have told you this many times, couple of times I guess. So if a light is coming and it is reflecting completely, if a light is incidentally and reflecting completely, which means this is is 100% reflecting surface, then it is reflecting, which means the total momentum will be u plus, P plus P. Okay, it will be P minus P. That will be u by c minus of minus u by c, which is equal to 2u by c. That is what is given here. Okay, so 2u by c, because it is 100% reflecting, the change in momentum will be 2u by c. Okay, so that is the first thing. And then radiation pressure. Okay. Okay. So this is nothing but, look at this, radiation pressure is the momentum imparted on the surface per unit area. That is what is radiation pressure. Again, once again. Yeah. Radiation pressure is nothing but the momentum imparted by the light on a surface per unit second per unit area. That is what is radiation pressure. Again, the momentum imparted on a surface by the light, the EM waves, per unit area per unit second. That is what is radiation pressure. So, for a reflecting surface, PR, that is radiation pressure of reflecting surface, will be 2S by C. Look at this 2U by C. Think about in that direction. 2S by C. So, for absorbing surface, it will be S by C. Okay, there will be a change in reflecting surface, there will be a change. So that is why 2S by C. Alright, this is the equation. Radiation pressure. So momentum imparted per unit second per unit area. That is what is radiation pressure. Alright, the final one, wave impedance. Okay, so wave impedance. What is wave impedance? When electromagnetic wave moves in a particular medium, there will be some hindrance towards the propagation of wave. So there will be some hindrance of the propagation of the wave. So that is known as wave impedance. So you know what is impedance, right? In alternating current, we have learned about impedance. This is some impedance which is acting on the against the propagation of electromagnetic wave. This is known as wave impedance. And Z is equal to root of mu by epsilon. Root of mu by epsilon. Okay, so these all are the properties of electromagnetic waves, and you go through the material, and if you got any doubts, you ask me. Okay, thank you.